Hello everyone. Today's video is all about piecewise functions. So in this video, we're going to take a look at the piecewise function down below here. We see that it's really a graph that's split into three parts. We have this parabolic shape over here. We have this parabola that gets cut off, and then we move over here to this little linear function, and then we have this different linear function over here. So we're looking at really three different functions that create this entire piecewise function. And for this graph, we do want to be able to state some pieces of information. So let's go piece by piece. Our domain, first of all, is our x values. So if you think about scanning our graph from left to right, we want to be able to see what x values are and are not accounted for. So the first thing I'm looking at is the fact that I have arrows in this negative direction. So that symbolizes to me that my function is going on forever and ever. In fact, we can symbolize that as negative infinity. So as we scooch along our graph, we start out in this negative infinity direction, and we do continue to going. All these x values are accounted for. This solid dot here means that this is an included value in the graph, as opposed to this open dot up here, which is a not included value. These do overlap each other, so this x value of 1 is definitely still a piece of our graph. We again continue over. All these x values are accounted for, again, including the solid dot here and the open dot below it being unaccounted for, but we still got 2 up here. We still continue going, and again, an arrow symbolizing infinity. So in fact, we have every single x value that is accounted for. So when we go to state our domain for this piecewise function, we are going to state that it's negative infinity to positive infinity. Now let's talk range. Range is your interval of your y values. So we want to look for, again, our lowest y value, our highest y value. Our lowest y value would be here at this vertex of the parabola. So that's where the y value is 0. And that is an included value, so we are going to want to go ahead and put a bracket on that. And now let's keep going. So as we are going up in our graph now along our y values stop over here, but they do continue on this left side of the function. So y values between 1 and 2 are definitely still accounted for. And as we get over to 2 here, we get the y values are accounted for on in this third function here, and they're also accounted for in this parabolic function to the left over here. So we definitely have all of these values accounted for either in one place or multiple places, again going on for infinity. So we can state that our range is 0 to positive infinity. So domain again is all your x values, range is all of your y values. Next, we're looking for our intervals of increase and decrease. So let's go through, let's highlight here some of our intervals of increase and decrease. If we're going to go through increasing first, so I'll make that yellow. Increasing values are when your values are going up. So you're going in this positive direction as you're reading your graph from left to right. So if I'm looking for a positive interval, it may be easiest to see here that we have this piece of our piecewise function that is definitely considered an increasing portion of our graph. Another increasing portion of our graph would be this portion of our parabola down here. Now, if we look to decreasing, so I'll switch up my colors, the decreasing portion of our graph is now we're looking for a portion that goes downward. So again, reading our graph from left to right, we see that all these values here are decreasing. This portion of our graph up here is neither increasing nor decreasing. It is a constant function, so that's not going to be included at all in our answer when we're going to state our interval of increase and decrease. So let's see here. So interval of increase then, if we go from left to right, it's definitely going to be increasing from 0 to 1. So that's going to be my first interval, 0 to 1. And at those values, your function's neither increasing nor decreasing, so I do put those in a parenthesis. And then as part of our set notation, we have more than one piece of our set. We put a U in the middle, so it represents a union. So we could say intervals from 0 to 1 are increasing, and then also the interval from 2 to infinity, 2 to infinity are increasing. So 2 to infinity. All right. Interval of decreasing then, again, we said that started out in our negative infinity direction, and our values were decreasing all the way down to 0. So negative infinity to 0 are all of our decreasing values. Next one's hopefully pretty easy, x-intercepts and y-intercepts. So our x-intercepts are located any place that our function crosses our x-axis. So if I switch up my colors, my x-intercepts is right here at 0, 0, which is coincidentally also my y-intercept, 0, 0. So the most important part to remember when stating x and y-intercepts is that these are ordered pairs, so they just need to be written as such. Some students like to say that the x-intercept is 0. It's like, well, no, x equals 0 is actually an equation for a line. It's not an intercept. So please make sure that you write your x and y intercepts as ordered pairs. The last portion, or the next portion here, is asking about the average rate of change from from 3 to 4. So let's take a look back at our graph at the x values between 3 and 4. So if I'm going to look here, let's make this a little bit thicker so we can see. So 3 is over here. Ooh, okay, maybe that's too thick. Try again. From 3 to 4. So I'm going to look here, and then 4 is going to be up at this point here. So I want to know what's my average rate of change, aka my slope, from this point over to this point. So, well, I'm counting up 2 boxes and over 2 boxes. But make sure that you take into consideration here what we are counting by. So each box, it looks like, represents half of a point, half of a coordinate, because here would be 1, right? Here would be 3. So by me going up 2 boxes, I really went up 1 unit. Same deal as I went over 2 boxes, I also went up 1 unit. So we would say that the slope or average rate of change between 3 and 4 would just be 1 over 1 or 1. So the average rate of change, you might also see AROC. Some people like to abbreviate it. Average rate of change is equal to 1. Next portion, evaluating. Evaluating at a point is just reading a graph. So if we go through, f of 2 is asking when your x value is 2, what is the corresponding y value? So let's go back up to our graph. When our x value is 2, our corresponding y value. Now recall here we had the open circle at 2, and then the closed circle up above it at 3. So the closed circle is the included value. The open circle is the not included value. So f of 2 then, we would say is 3, because that's where the closed circle is. So f of 2 is equal to 3, or you can simply write f of 2 equals 3. Either way that you state that is completely fine. Determine the value of x when f of x is equal to 1. So now this is going the other way. If we're thinking about the ordered pair solution to this, we need to determine the x value for when the y value is equal to 1. So let's go back to our graph. Our y value is equal to 1. We said over here. So when is our, for what x values do we have? Well, actually we have 2 answers for this one, right? Because y is equal to 1 at this point over here. So that's when x is equal to negative 1. So that's one solution. The other solution is over here. So when x is equal to positive 1, y is also equal to positive 1. So our answers are actually both positive 1 and negative 1. So determine the values, plus or minus 1, comma 1. So evaluating, this is saying the same thing as y equals, and then look up at the graph. This is the same thing as saying x equals, and again, looking up at the graph. All right, thank you so much for watching the video. See you next time.